So the next talk will be by Bill Idsardi and Jeff Hines on stress computation in the Chomsky hierarchy.
Thank you. Thanks for inviting me. I've had the great good fortune during my career to work with a number of marvelous people, Morris being one of them, and I had the weird experience of having been hired away from Delaware, that the person who came to replace me, then I've in fact worked with him ever since. So this is stuff very similar in some ways, I suppose, to Alan's talk, and I'm sure that Morris will have the same complaint about my talk, is that it contains no actual examples. So we'll go forward with this and talk a little bit about the relationship between phonological generalizations in the Chomsky hierarchy, work that Jeff and I and several other people have been conducting. And we'll start with a question that is infamous, maybe in phonology, why phonology is different. Morris and Sylvan offered one explanation of this difference, and we're going to offer a slightly different one. And so what we're going to say, or what the thesis of this, is that syntax and phonology differ in their computational properties, differ in their place in the Chomsky hierarchy is one way to put it. And that what we have seen so far, and this goes back to some of the things that Alan was citing, Irwin Howard, C. Douglas Johnson, Kaplan and Kay, and so on, is that all known phonological generalizations are finite state or within the class of regular languages, including stress generalizations. And we know from other work, much other work, in fact, the very early work by Chomsky, that some syntactic generalizations involve power beyond push-down automata, that is, like the convergent opinion at this point that syntax is probably somewhere in the mildly context-sensitive region. And we'll have diagrams of this in a minute. And the discussion will mostly be in FSA terms, but one of the interesting properties of these things is that you can translate one sort of description into any other description. So you can talk about it in terms of languages that they generate, or in terms of logics, or in terms of automata. We presented some of this material before, just as Alan sort of said too, at the conference for Jean Roger, and some of this other stuff was in science and topics in cognitive science this year. And there are some good consequences for this idea that, in fact, phonology is low-powered with respect to syntax. If, in fact, it's within the class of regular languages, or, in fact, a stronger claim that we'll try to make, that it's sub-regular, that it's within a class that falls below that, then we can make stronger claims about what it constitutes a phonological generalization. There's a smaller class of objects that would be legitimate phonological generalizations. Other learning algorithms become available to this, so you don't fall into certain sorts of learning problems. And as Bob Berwick has emphasized, maybe this also answers a question about how you're supposed to compare across animal behavior. So, you know, if for a long time people look at birdsong and the answer has been, what's the syntax of birdsong? And nobody ever says, well, what's the phonology of birdsong? But maybe that's a better analogy to the birdsong problem than the syntax is. Okay, so here's the familiar picture of the Chomsky hierarchy. With the finite languages, that is just a list of items, right? A non-extensible list of items. At the very bottom, the regular languages are usually the class that people worry about that properly include the finite languages, then context-free, context-sensitive, and, you know, eventually recursively enumerable. So there are also annotated in this various sorts of patterns in where they fall. So as I said before, the patterns of generalization for phonology fall within the regular class, and there are various sorts of syntactic generalizations that fall outside that. We want to, the side says we want to exclude the finite languages. This is really important, is nobody comes into human language thinking that they're learning a finite list of possible, say, forms of words, right? So it's got to immediately generalize into characterizations of infinite sets. And, you know, some learning algorithms can do that and some can't. The one that you typically get from psychologists is collect the list and then look at it. And that one doesn't actually achieve that. So phonological generalizations seem to consist of a small number of sub-regular types, that is, generalizations that fall underneath the regular class of languages, don't need the full power of regular languages. This was work that Jeff did in his thesis and subsequently. So one class of these you can think of as like co-articulation made grammatical. So these involve adjacent elements of some number of elements, right? And so these would be called the strictly local generalizations, those cases where things are touching one another, adjacent to one another, the contiguous substrings of link K. So it has a parameter associated with a K, which is how long the thing is. So if you're looking at pairs of items, it would be strictly local too. And there's been a fair amount of sort of work investigating what sorts of generalizations people can learn or not learn from artificial learning, language learning experiments. I'll talk about those briefly later. Another class of things is essentially you can think of as a generalization of the idea of action at a distance. And so these are the strictly piecewise K. It's also parameterized, but it seems to be always 2. So these are the generalizations that involve things that are not next to one another in the string, so that they can be any distance apart. And I think in some way this represents a formalization of an idea that Morris expressed in his LSA lecture in 1975 with looking at the essential variables in phonology. What could go in between two things that were interacting with one another? So this is sort of pure action at a distance at this case. And then finally there's a notion in Jeff's thesis that he uses to analyze certain stress patterns, and this was published later too, where you look at constructing a state map, a finite state diagram for the positive examples that you have, and then you merge states according to some criteria, in this case neighborhood distinctness, and this automatically sort of introduces cycles into the finite state machine, which will then allow you to analyze infinite sets of strings, right? Unbounded strings of unbounded length. I'm not going to talk about that one very much because it doesn't have a clear characterization in language theoretic terms. So the subregular region is inside the regular languages, and it has structure inside it too that's much like the structure of the Chomsky hierarchy in general. It cross-classes the finite languages, but as we said before, we're going to exclude those from consideration anyway. That's not what we're trying to learn. So the subregular part of the subregular hierarchy is here. So the regular languages constitute a covering for the entire set of things that are inside this. This is a lattice, just like Alan's lattices. And underneath that, there's a major class of items that were examined by McNaughton and Papert called the star-free class or the non-counting class. So this is a class of things where you're not allowed to keep track of modulo n where you are in the string. And this will come up as being like a question for stress theory, if you're going to take an automata approach to it, whether we need that or not. Underneath these, there are various sorts of classes whose have names there, and they form this sort of hierarchical arrangement so that star-free is a broader class of languages than, say, the class of languages that are described with only strictly local constraints, which are at the bottom there. So the ones in blue, tier-based, strictly local, strictly piecewise, the idea is that all basic phonological generalizations come from one of those 3 types. Right? And so this is independent of whether you want to think of them as sort of, constraints, or the form of constraints would fall into one of those 3 classes, or other rule-based approaches to this. So it's agnostic with respect to that question for the most part. And so then the question is, can we do that? Is this sort of a program for phonology? Can we show that all the generalizations, all the basic generalizations that we need fall into one of those 3 classes? And as I said before, there are sort of convergent definitions for these classes. So you can have a language theoretic definition, an automata theoretic, and a logical definition. So for instance, the regular class of languages are those that are described by finite state automata, or by monadic second order logic, or the star-free class is the equivalent to what you can describe with first order logic. So here are the tempting claims that there's room at the bottom, that there's actually structure inside the regular language, interesting structure inside the regular languages to be exploited. Here's another one that maybe phonology is in fact less powerful than exhausting the regular class of languages, that it can be restricted to star-free, that the grammars that you'll construct for this will be star-free, non-counting. That one we'll come back to. The individual generalizations are either strictly local, tier-based strictly local, or strictly piecewise. And the net upshot of that is the same thing that Alan was saying, is that factorization works, is that you take some terribly complicated pattern and reduce it to its component parts that combine together somehow. Of course, that's a science, I think. So, and so that then we can hopefully find those factors, find those individual generalizations easier than we can find the whole system thrown at us, right? And so that's another talk for another day. Coming back to this artificial language learning, we see that, in fact, the findings from this artificial language learning literature, which is exploding, people like to do this. So you have kids come in and you give them like 5 minutes worth of a language, and then you say, what do you think, is this in it? And surprisingly or astonishingly, they can actually do this. So you can do it with children, you can do it with adults. And the findings from this are like sort of, in one sense, not encouraging to typologically oriented phonologists, because they seem to be able to get unattested generalizations quite easily. So in particular, Cynthia Fisher and colleagues and Amanda Seidel and so on have looked at generalizations where you take a reasonable phonological generalization, let's say Seidel's case of lenition, and then you reverse it. And the children are just as happy, the people in the artificial language learning are just as happy to learn the fortition in the lenition environment as they are to learn the lenition in the lenition environment. So in that case, it looks like the function that the thing is, it doesn't really matter to the kids, but the form does seem to matter. And so in a series of experiments that she conducted with Jeff Heinz, Regine Lai, who's now at Maryland with us, looked at trying to compare syntax-type generalizations versus phonology-type generalizations, varying only the presentation of the material as having sentence-like prosody so that you could hear each syllable qua word, and phonological-type prosody where you crammed all the syllables together and it sounded like one big word. And in that case, she gave them center embedding-type generalizations, and when they were presented as word-like things, they were able to find it, and when they were presented like a single word type thing, they were unable to find it. And even things that, so that was a case where we were comparing a context-free generalization with phonology. But even inside the non-strictly local, tier-based strictly local, strictly piecewise class, so regular languages that are outside that. So one of this is just harmonize the first and last elements, but don't harmonize anything in the middle. Right? And so this falls outside, turns out, the class that we're talking about. The children don't want to learn that. So even though first and last have some psychological priority, as everybody knows, that doesn't seem to be available to them as a restriction on the generalization. So they don't want to make that generalization that the first and last things will harmonize, but the things in between won't. And if you try to swap the form of the generalization, so if you write a devoicing rule like it's a stress rule, or write a stress rule like it's a devoicing rule, children don't like that either, right? And so that was work that I'd done previously with Erica Bergelson. Okay, so then what does it do to make a grammar? Well, as Alan said, I mean, what you do is you take these basic generalizations and combine them together somehow. And so systems, we want systems like Alan's systems that have nice properties to them. And so the regular languages do have nice mathematical properties which allow them to be combined together into grammars. So if you take the individual generalizations, then you have a bunch of logical operations that you can perform with them, like union, that is, or intersection, complementation, difference, concatenation, cleaning concatenation, reversal, homomorphism, and so on. And it's closed under those things. You don't exit the regular languages by taking those individual generalizations and cramming them together. You still stay within that class. And so what I've said in other work, I mean, Jeff has said this more politely. So he says, like, okay, so that what that means is that this automata theoretic characterization of things provides a lingua franca across theories. Like, so you can code up OT or rule-based phonology as a set of generalizations within the regular class. The way I've said this before, grabbing the thing from course 270 here, is that it's like a stage for BattleBots. BattleBots was a well, it was a TV show, but before it was a TV show, it was a course here at MIT where you got a package of materials and you had to build something, and eventually it got like too violent, I think. So, they don't think they have it anymore. Woody Flowers isn't there anymore. And so what we also would look at is that some points in that subregular hierarchy will have similar closure properties to them. So, so that you'll be able to put the generalizations together and you won't exit that class. And the interesting one that's under, or the one that seems to be interesting that's under the full class of regular languages, is that starfree or non-counting class. Right? So that's the sort of, where the focus is. And other people have pointed this out too, like Andras Kornai. Okay, so metrical stress theory, as Alan also said, is a wonderful place to look because we've sort of, at this point, come to a consensus about the sort of things that we need to do, right? So metrical theory has to be able to handle respect for pre-existing structures. So if there's lexical stress, you need to respect it in some way. It has to be able to handle correlations with other phonological properties of limited sorts, so weight to stress. It has edge effects, like edges are sometimes different than you would expect them to be. And the big thing, which is going to be the question about the counting, is it seems to have repeating patterns, right? So you can lay down a pattern across a word. And finally, it has this property that I think was a bugaboo for you too. Like, what do you do with these cases where you want to say there's a long form and maybe I don't want to put any stresses in it at all, right? So this idea that one and only one primary stress per word, that actually, like, sort of, you poke at that and it's not so easy. So here's some examples, just what the machines look like. The machines are incredibly simple for most of the cases. And Jeff will have a poster later today on stress type, and it allows you to search on sort of patterns like this. So you should go see that. So if we take an example that's just incredibly simple, put main stress on the first syllable, there are no secondary stresses, and I'll just mark that as main stress is P and secondary stress is S, and an unstressed syllable is U. Then that language can be described by the set of allowable pairs of things that you'll see in any given word. So you can start with a primary stressed syllable. You can find sequences of a primary stressed syllable followed by an unstressed syllable. You can find sequences of unstressed syllables. You can find an unstressed syllable at the end, and you can find a primary stressed syllable at the end in the case that it's a monosyllabic word. So that set of pairwise things that you're looking at across the string, if your string meets that, if your string has nothing outside of that, then it falls into this class, right? And so that would be a check, a local check that only involves looking at pairs of things to see whether you're in this class, right? So it's a limited memory sort of system. In fact, it's like almost no memory. And there's the finite state diagram for that. You come in, you go to a primary stressed syllable, and then, there's some number of potentially unstressed syllables afterwards. So this is an example of a strictly local, for two elements, generalization, right? Okay, so that's a simple case. So then, the characterization of that machine is quite simple. So you might think, and in fact, it's been very popular to think, one way to assess the relative cost of the generalizations is the number of states in the machine, the number of transitions, and so on. It turns out that's not a good way, even though it's tempting, and it's what I had suggested. So here's like the machine that does commutativity, that says like there's going to be a primary stress someplace in the word, and you have to see it. So you can be in state 0, you can see unstressed or stressed syllables as much as you like. Eventually you're going to hit a primary stressed syllable, and then you need to have only unstressed or stressed or secondary stressed syllables after that. Right? This will do that. There'll be exactly one, if this machine halts properly, there'll be exactly one primary stress in the word. Because you had to go across that boundary, couldn't stop in state 0. You had to go across that boundary to state 1, and then state 1 doesn't allow you any more primary stress materials. And that machine is no more complicated in some sense than that one, right? I mean, like, what did we do? We just put an arc on the first state, right? So it's not necessarily that much more complicated than the previous one, but this turns out to be not it's not as easy in a generalization. So what we want to do then is factor that notion of one and only one stress into its component parts. And so its component parts of, exactly one is at most one. There's at most one stress. There might be 0, but there's at most one stress, right? And there's at least one stress, right? So those two generalizations taken together, if they both hold, if you intersect those two generalizations, then you'll get the right answer. And so at most one is a simple, strictly piecewise two generalization. No primary stress can follow a primary stress in the form, right? So that's at any distance, right? And so this would, if there were 14 of them, it would still violate this, right? Whatever, as long as you would match that thing where there's a primary stress and another one, that would be bad, no matter what intervenes in the middle, right? So that's a strictly piecewise two generalization. At least one turns out to be a little bit harder. So it's not within the class of strictly local or strictly piecewise. It's in like the next layer up from either one of those. And one way to sort of think about this is to take that pairwise factoring that we did for the language that puts primary stress on the initial syllable and add a couple things to allow us to drift the primary stress someplace in the word, right? And the things that we would seem to need to do to add to that set would be to say, oh, we could start with an unstressed syllable, and we could see a sequence of an unstressed syllable followed by a primary stress someplace in the word. And that would seem to be enough to get us from like sort of saying, okay, the stress is on the first syllable to just the stress is someplace. But that actually doesn't do what we want it to do because it allows just for an unstressed syllable by itself, right? That string is valid under that case, or it allows for any string that's just unstressed syllables all because it's going to start with an unstressed syllable, it's going to have a sequence of UU all the way across the form, and then it's going to end with an unstressed syllable. So like, it turns out there's no class of things that you can put together for strictly piecewise two or anything that will cover this case that won't eventually allow a long enough string not to have a primary stress in it. You can do it like for the short ones in all cases, but you're going to reach a point where you can no longer do that. But what we would like to do then eventually is to intersect those two generalizations and then stay within a class. Now it turns out that the class that those two belong to is covered. And it's covered by maybe a couple of things, but in particular it's covered by the non-counting class, this starfree class. So we're getting another case where we put these together and that seems to be, we're pointing at that class again. Okay, so there's a problem. So Thomas Graf pointed this out several years ago. He also addressed this question of the counting versus non-counting systems. And the languages, unsurprisingly to people who are familiar with stress theory, that are now going to come back and bite us are things like Greek and Kyrene Arabic. And everybody sort of knew this because they're the interesting cases. I mean, they're the cases that you work up to in when you teach stress theory. So stress falls on the, everybody knows already here, I'm sure. It's on the next slide because it's like sort of long. If we keep the secondary, if we thought that there were actually secondary stresses, then the primary stress is going to be located within spitting distance of a secondary stress, right? If we actually lay down secondary stresses, we'll be able to see it. And the problem is that the things are reported as not having those, right? And so then you have to sort of keep this count without actually being able to see it, right? And that's the essence of the question. I mean, is there abstract structure that we need or not? So there's the generalization. It falls on a final super heavy. It falls on it falls on the heavy penult. And then, this last even syllable counting from the rightmost heavy syllable, or the last even, if there aren't heavy syllables, counting from the beginning of the word, right? And it's that counting that would say that you're maybe not in the non-counting class, like unsurprisingly. So that's the question. If the counting involves checking something that's visible, like a sort of secondary stress characteristic, then you can just pivot off that. And the generalization is, oh, you're going to be on the second syllable away from the primary stress that you laid down. So that's a strictly local generalization, but if you can't see it, it isn't. In essence, we need to count modulo 2 for arbitrary distances, and that we can't do within the starfree class. It's well known. First-order logic can't count modulo n. Since first-order logic is equivalent to the starfree class, you can't do that. So the question then that comes up in this automata theoretic world is stress beyond starfree then. I mean, so like what is this? And obviously the one answer to this is then you would like further investigation of Greek and Kyrene Arabic, right? We want the scientific method to feed back on itself. Here's a case that now we're super interested in. Let's go check. I mean, and there are in fact there have been more recent papers on Greek. The other possible answer to this is then unseen structure, which has been the answer inside generative phonology for a long time. If you put down feet, maybe then the generalizations must require those. Overall, Jim Rogers has been looking at this with his students, examining the stress type database that Jeff and Harry's here too, right? Have been putting together, and looking at the patterns that you could do by combining these sorts of generalizations. So if you take strictly local generalizations and strictly piecewise generalizations and put them together, then you can account for, in various ways, you can account for 89 of the 109 patterns in the database. If you add this sort of question of piecewise testable, which is the next thing up from strictly piecewise, you can get a few more languages. If you do the locally testable, which is the next thing up from strictly local, then you can do a few more. There seem to be no languages that need starfree power by themselves if you are able to make both strictly piecewise and strictly local generalizations. And then there are a few that fall beyond starfree, like the case we had before, so Kyrie in Arabic. There are maybe, though, deeper similarities. So the end game to this entire project would be to try to come back to that question of why phonology is different. So, okay, it's different on these computational properties, but why might that be? And so ultimately we would like to, and this is, the Chomskyan perspective, we'd like to reduce the difference between, say, phonology and syntax to one minimal difference if we could find it, right? And so we've been describing the phonological generalizations as non-counting primary generalizations over strings. And some work by Ed Stabler and his students suggests that, although I don't know how far they are along in this proof, is that the region of mildly context-sensitive languages that that literature is converged on looks like they can be defined by local and piecewise automata over trees. And so this is easiest to sort of get the picture of if you think of tree adjoining grammar cases where you're able to stick pieces in between of arbitrary difference. If we could get to this point, then the conclusion that we might be able to draw is that you've got strictly piecewise generalizations, strictly local generalizations, those sorts of types, over strings gives you sort of phonological generalizations, and those analogous operations over trees gives you syntactic type generalizations. Now, I think that this would start to try to solve a puzzle that Chomsky has really been pushing the last few years, which is not only why does syntax have hierarchical generalizations, but why does it lack linear generalizations? I mean, it'd be one thing to sort of say, okay, I've got this linear system that I can make generalizations about, and now I'm going to add something to it, something minimal to it that will give me syntax, right? And so I would add the ability to make hierarchical generalizations. But why does that take away my ability to make linear generalizations? Well, there seems to be a sort of trade here that the tree encoding for syntax has somehow supplanted the linear encoding that the phonology, which I'm assuming is sort of evolutionarily prior, had, right? So it's like reusing a part of the system to code something different. So it's using what you were using to code linear relations to code hierarchical relations, and in so doing removes your ability to even talk about linear relations, right? So that's the real end game, is why are there no linear operations? What's the deep difference between phonology and syntax? And the hope at the answer is it's the difference between strings and trees. Thank you. How'd I do?
So we have some time for questions, and we'd like to request that questioners come to the microphones to ask your questions.
Sylvan. Oh, okay. Well, Sylvan had his hand. I think you can get to them. Well, I don't know everyone's name.
Just a very simple question about your last point. And that phonology doesn't have merge. Syntax has merge. Is that relevant at all?
Well, I don't know that phonology doesn't merge, but if it merges, merge in phonology is concatenation. Mm-hmm. Right? I'm perfectly happy to say that, this concept of merge, which is, as far as I can tell, just combine.
Yeah, but internal merge, I should have said, rather than plain merge.
Yeah, okay. I don't think I'm prepared to have a debate about the ontological status of internal merge in syntax. Yeah, that's true. You don't seem to see that inside phonology, and so I'm not sure that. I've never Okay, I guess I am going to say this. So I've never really seen that. I've never really bought that argument that internal merge has, you get that for free once you have merge. That's non-obvious to me, right? That you could take two separate things and put them together, and that would imply that you could take some subpart of yourself and put it together with yourself. I've never seen that as following logically, but Chomsky begs to differ, right? Up at the top, yeah.
Ray Jackenduff, Tufts.
Hi.
Hi. I actually found this very interesting and encouraging because in the version of syntax that I've been working on, there are both kinds of rules, both string and hierarchically based principles. So maybe there is hope after all, and that's not a puzzle.
Yeah, no, and, say Juan Uriagreca, he says the same thing to me. It's like, that there are these certain constructions that he thinks are, he loves his word Markovian, right? So he has the same point of view that you do. I think it's...
Yeah, I don't think it's...
Well, I don't think it's... Yeah, no,
it's
not in every
Markovian,
respect,
yeah.
but on that.
Yeah. Mm-hmm.
Andrew Nevins, University College London. I try to find a lot of the similarities between syntax and phonology, and I think some of the insistence on why phonology is different sort of I happened to talk with Thomas Graf yesterday about his Creek result, and I said, why don't you guys just use feet? Because the syntacticians, when they compute the Chomsky hierarchy, give themselves constituency for free. And so it seems like there's almost a reification of this difference by not including the units, the higher level hidden units. And the other question is, why is sort of reduplication, Pig Latin, all the fun language game stuff sort of relegated to the margins and not, that's kind of like pure birdsong, if you wish. That's...
Thanks. Yeah, no, I agree with you on both points. The thing that we see, though, is that I don't think that reduplication is strictly speaking, a phonological generalization, right? So I don't think that what you're trying to do is say that, there wouldn't be a language that sort of said under this condition, right, then, any string that's valid is going to be a reduplication, right? So that's, you're not going to have a process of, it's hard to even come up with what it would be inside phonology, right? So there's an interaction between the morphology in that case. Now, the question about whether it takes you beyond regular languages, my answer to that has been the answer that I took with Eric Ramey, is that the representation that we have actually is a finite state diagram, and that the restriction on the number of loops that you go through the thing is handled by something else, right? So the representation that you have is still within regular power, as it were, but then when you go to say it, right, there's some sort of other operation of, in this case, like a kind of optimality calculation, but it's already known that certain sorts of optimality calculations bring you outside of regular power. This was Karttinen's argument. So, yeah, this is, it wouldn't be an interesting research program if it couldn't be wrong, I guess. Bruce, then Harry. Oh, sorry.
Harry VanderHolst, University of Connecticut. With the system like Creek and Kyrene, I'm becoming increasingly suspicious that we actually analyze them in the right way. We assume it's one system, but it's very possible that there is something rhythmic going on, and then at some higher level, later on, there is a prominence located on the left or right edge, and if that edge happens to be the opposite one, so it's not. We sort of run away with these examples, and I'm sure that Bruce could comment on this too. But in many of these cases, it seems that it may not be a single system at all.
Right. So then the question is, if you think, so that's the question about the closure properties. So it may not be a single generalization, right? And in fact, that's what we're trying to do, is to take things that look too complicated as monolithic generalizations and factor them out, right? So factor them into their parts, right? And then the question is, well, okay, if you do that and you're in a system that has closure properties, then you can't get outside of that, right? So the regular languages are closed under all those operations that I talked about. So like if you found a non-regular pattern, there has to be something that's contributing the non-regularity to it, right? Because otherwise you're closed under those operations inside that. So if those are the only operations that are available to you and all basic generalizations fall into that class, you can't get out of it, right? So that's the interest of the closure properties, right? And so like this, with the question of the starfree then question, like even, so I mean one answer would be just the answer that Graf gave. If the secondary stress, if the rhythm is somehow visible, then it's not a problem, right? But if it's totally invisible, then that's when you need to count modulo n without like being able to keep track of where you are, as it were. Yeah. Yeah, Bruce? Then.
Bruce Hayes, UCLA. I have a follow-up on Andrew's question. So if I understand you rightly, you're saying that morphology is not finite state, but phonology is?
Well,
right?
No, actually, the answer that
but
we gave
in
to
the sense
was
that morphology
the
allows
object
copying. That's what I want to focus on.
Yeah, go ahead.
Yeah.
Whatever you like.
There is a question that emerges from this preamble, by the way.
Jeff Hines, University of Delaware. I'll keep it short, but I would say that you can divide morphology probably into morphosyntax and morphophonology, and so the total reduplication examples, those are definitely be outside the power of the regular processes. But if you look at partial reduplication, all those actually seem to be inside the regular class. So I think morphology proper might be better thought of as a distinct, from the computational perspective offered here, can be split into morphosyntax and morphophonology along these lines.
Do you want your follow-up?
I do want my follow-up.
Yep.
So this is more addressed, I mean, that's very helpful, but this is more addressed to your skeptics than to you. I feel that certain phonological generalizations have a diachronic origin in morphology. So quite a few languages, for instance, have roots that look reduplicated, but the reduplication has no morphological justification. One might also add the famous fact about Semitic that John McCarthy originally brought to theoretical attention, that you can have roots like, say, samam with reduplication violating, where it's copying that overrides an otherwise general OCP phonological principle on root structure. I wouldn't be surprised at all if in deep, deep, deep Proto-Semitic things like samam were reduplicated forms. So that's where I think you're likely to run into trouble. It's the things that aren't necessarily natural as phonology, but have some kind of deep diachronic origin as such.
Right, yeah, and so then the answer that and this one is incompletely tied to what I said today. So the answer that I've given to those cases before is that you have to enrich the power of the representation of the lexical forms to include graph structured objects instead of just strings, right? And so then those graph structured objects have to be output as linearizations of those things. Right? This is the work with Eric Ramey. And so, then your question is like, so what's the status of those sorts of things? So those sorts of things are just finite state machines at the moment. I mean, so the representation of the possible lexical forms doesn't seem to draw us outside the class of things, but then it underrepresents in a certain way the reduplication, because it also would characterize a thing that was not just banana, banana, but banana, 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 banana. I mean, you could have as many repetitions of that as you want, and then we're saying that the fact that you only get 2 repetitions of that is not part of the system. I mean, it's part of the externalization, right? And so that calculation that goes on, which actually isn't representable finite stately, is outside, is part of an interface into, say, the motor system, right? And so we're trying to draw that out. And so then the form of the generalization that we have within the phonology is overly powerful, overgenerates the forms that are actually seen, and we want to sort of, again, factor that piece out and sort of say something else accounts for that.
Thank you.
Thanks. Lisa.
A little
puzzled by this characterization of phonology versus syntax. I'm speaking from the point of view of phenomena of phonology that might apply within a sentence. There are certainly plenty of cases that you have where the, for example, extent of spreading of a high tone or some such thing is subject to conditions that come ultimately from the syntax via prosodic structure representation. So how do those kinds of things figure into this?
Well, I hope this isn't just an advertisement for you.
As being, based on strings and
right. But I hope this isn't just an advertisement for you. But my answer would be your answer. So so as versus say Ellen Case's answer. So Ellen Case, sort of said, okay, well, we have direct access to concepts from the syntax, like C command, so that this phonological rule can operate under this C command condition. Right?
Does it matter whether it's case versus is the sensitivity direct to the syntax or to a prosodic structure in the characterization of a distinction between phonology and syntax the way you gave it?
Yeah, so what I think goes on, and there's a point at which my opinion differs from yours, but what I think goes on is that you take the syntactic structure and crush it. I mean, this is essentially the answer that was given in SPE2, right? Is so that you take a recursive structure and render it non-recursive. Right? So you crush it down, and then now the domains that result from that by edge rule or whatever, whatever system you want for that, those are now the domains of application for the rules as you had them. Right? And that differs because it takes out the detailed syntactic information and converts it to phonologically readable form, right? That differs from, say, the view that Ellen had, that you had direct access to those syntactic constructs qua syntax.
Well, let's not argue about the various versions of how to characterize the domains for phonological phenomena, but so you're basically saying that something like if you can just demarcate edges of things, and that becomes just something equivalent to a boundary, in effect, and so that the characterization of phonology as being simply string-based is would hold.
Yeah.
Well, incidentally, talking about advertisement, I don't believe in this crushing anymore. Rather, that the phonology does require access to a recursive structure that's inherited from the syntax. So.
Right. No, I know we differ on this point, and so did Bob Ladd and so on. So yeah, I mean, I want to see it crush it to a non-recursive structure, and other people would like limited amounts of recursion.
We have time for just one quick question.
Yeah. At the top, I can't see who you are. Come to the mic, though.
My name's Kim, self-directed study person. Has there been any expansion on the Filipino GRAS database that was created a while back? I've been spending a lot of time looking at the connections between like Pashto and Dari and Egyptian and looking at the evolution between the script all the way, the symbol to the script, and as it relates to like 4 main subsets, so like as it's broken down by hemisphere, how it's changed, and then just by dialect, how the writing style changes within each language, and then also considering seasonality and things that you get to see within those progressions, specifically focused on Egypt and its roots back in the Romance languages, all the way to Pashto and Dari, because you have that pass directly in between China and Afghanistan, and seeing why Pashto specifically is so deeply rooted in that guttural, like Mandarin accent. So I was just wondering if there's any analytic corpora that can go farther into this exploration, because I think I've found quite a few connections.
All I can say is, like, so first of all, that's not my area. So, but second,
I'm sorry.
so, like, I mean, if you want to know more about Pashto, there is this group at the Center for Advanced Study of Language at the University of Maryland, and because Pashto is a language of interest, that's sort of where the main, that's got the biggest group of Pashto researchers in the world. Right, because in fact they're worried about them attacking something. So, so the Center for Advanced Study of Language at the University of Maryland, that'll be your best bet. I'm sorry, I don't know anything more.
All right.
Thank you. Okay, so thank you, and we'll have a break now and resume at 11:30.